All right, today we're going to dive deep into that amazing thing between your ears, your brain. We're going to tackle a really fundamental question about how you think, how you see, how you speak. A question that really gets to the heart of how the whole thing is organized. So let's just jump right in with the big question. Think about your brain for a second. Is it one single, all powerful supercomputer that just kind of does everything? Or is it more like a busy workshop filled with all kinds of different experts, each one with a very specific job? You know, a vision expert, a language expert, a moving your hand expert. That's the mystery we're going to unravel today. You know, for a long, long time, the leading idea, they called it cortical equipotentiality, was that the brain was basically one big, flexible unit. Any part could pretty much learn to do any job. But that idea got completely turned on its head by a new one, localization of function. This is the idea that we're talking about today, that specific jobs, like understanding words or recognizing your friend's face, are handled by various specific dedicated areas. It's really the difference between having one of those multi-tools for every job versus having a whole toolbox full of specialized instruments. So how in the world did we figure this out? Well, our detective story really kicks off back in 1861 with a French physician named Paul Broca and a patient who was about to change everything we thought we knew about the brain. See, Broca was studying patients who'd had strokes, and he noticed they had this very peculiar problem. They could totally understand what you were saying to them, but when they tried to talk back, the words just wouldn't come out right. Their speech was really slow, it was a huge effort, and the grammar was all over the place. We now call this Broca's aphasia. The key thing to remember here is that the problem is all about producing the language. To make this a little more real for you, here's a quote from a modern patient trying to explain what happened to them. They said, all right, stroke and Tawana guy, his hot tub. You can just feel the struggle, can't you? The thoughts are clearly in there, but actually getting them out into clear sentences is this massive, massive challenge. So after his most famous patient, a man who could only say the word tan, passed away, Broca did an autopsy, and what he found was the smoking gun. There was damage to one very specific spot in the brain's left frontal lobe, and when he looked at other patients with the exact same speech problem, he found the same pattern. For the very first time, a specific mental job, making speech, was tied to a specific place in the brain. We now call it Broca's area, and this was a huge, huge blow to that old idea of the brain just being one big blob. But hold on, the story doesn't stop there. Just a few years later, in 1879, a German doctor named Karl Wernicke stumbled upon patients with a completely different kind of language issue. And this added a whole new, fascinating layer to the puzzle. Now, these patients could talk up a storm. Their speech was fluent, the grammar seemed fine, the rhythm was totally normal, but the words they were saying were just complete and utter nonsense. Just a string of words that meant absolutely nothing together. This condition is called Wernicke's aphasia. You see the difference? It's not a problem with the mechanics of speaking, it's a problem with the meaning. So with Wernicke's aphasia, patients can't seem to connect words to what they actually mean. And because of that, they also can't understand what other people are saying to them. And guess what? Wernicke found that all of these patients had damage in a totally different spot, this time in the temporal lobe. This was brilliant. It showed us that language isn't just one job. Producing it and understanding it are two separate tasks, handled by two different specialists in the brain. So once Broca and Wernicke showed that language had specific addresses in the brain, it was like a starting pistol fired. The race was on. Scientists realized, hey, we can actually start to map the whole brain. And that map started to fill in really fast. Research, a lot of it from soldiers injured in wars, showed that damage to the occipital lobe, that's at the very back of your head, caused blindness. The temporal lobe turned out to be the headquarters for hearing. The parietal lobe was the main hub for sensations like touch and pain. And that big frontal lobe, right at the front, well, that's like the CEO of the whole operation, in charge of planning and problem solving. The brain wasn't just a mysterious gray lump anymore. It was becoming a detailed atlas. But if you're still not totally convinced, let me tell you about what might be the weirdest and most powerful piece of evidence for all of this. It's a condition that honestly sounds like it came straight out of science fiction. It's called prosopagnosia, or face blindness. It's caused by damage to a tiny little spot in the lower right temporal lobe. Now get this, someone with this condition can see a face perfectly clearly. They see the eyes, the nose, the mouth, all the features, but they have absolutely no idea whose face they're looking at. They can't recognize their friends, their family. In some cases, they can look in a mirror and not recognize the person staring back at them. How wild is that?
I mean, that's incredibly specific, right? But it brings up a really important question. How can we be 100% sure that recognizing a face is a different job from, say, recognizing a lamp? Maybe it's all just one big recognition system that's a little broken. How do you actually prove they're separate?
Well, this is where scientists came up with a really elegant and clever piece of logic called double dissociation. Just follow me here. First, you find a patient who has damage to one spot. Let's call it Area X. This person can't recognize faces, but they can look at a chair and say, yep, that's a chair, no problem. But then, and this is the crucial part, you find a different patient with damage to a totally different spot, Area Y. And they have the exact opposite problem. They can recognize faces just fine, but now they can't recognize everyday objects. When you have both of those cases, you've proved it. The two jobs are separate and handled by different specialists. It's the absolute gold standard for this kind of proof.
And this idea of a dedicated face area isn't just theory based on these unique cases. Modern science has given us an even closer look, leading to this pretty jaw-dropping number, 97%.
So get this. In 2006, scientists were actually able to record the activity of individual brain cells in monkeys. And they found that in one tiny little patch of the brain, a staggering 97% of the neurons they checked fired only when the monkey was looking at a picture of a face. They didn't care about hands or gadgets or food, just faces. I mean, it's pretty hard to imagine stronger evidence that there's a team of specialists at work in there. So let's bring it all back to that question from the beginning. Is your brain a single supercomputer? The evidence is pretty overwhelming that no, it's not. It's this incredibly intricate, collaborative team of highly trained specialists, each with its own very specific job to do. And that leaves us with one last really fascinating thought, right? If we have specialists for making speech and understanding meaning, and even just for recognizing faces, what other undiscovered specialists are still in there, quietly working away in the workshop of the mind?